Hello, I am Brock Stanton. I'm an aspiring meteorologist, and today we are going to be taking a look at this enhanced risk for severe weather across portions of Montana. However, a slight risk does extend across a large portion of the high plains. The enhanced risk is driven by 30% significant for wind, and this is due to a squall line that will likely develop in a moderately unstable and strongly sheared environment that and that combination is going to lead to damaging winds. There's not too much of a tornado risk with this system. It's fairly low. There is a 2% in portions of Nebraska and extreme South Dakota, but overall damaging winds, some of those being significant, again over 75 miles per hour, as well as hail, are going to be the primary threats with this system. We're going to take a look at our HRRR. And we're going to take a look here. And we're just going to see what the reflectivity output is, and then we're going to take a look at those parameters to kind of show how that situation evolves. And as we get into the day on Sunday, we can see there's a couple morning showers, but nothing that's going to significantly limit destabilization of the atmosphere. And we can see, as we get into the afternoon hours, these supercells develop, and these could produce large hail and damaging winds, and eventually storms congeal into a line, and they're going to move eastward. And here, if we go back over a little farther east, we're going to see how this line of storms continues to develop and move eastward, offering up damaging winds and large hail. That's the primary risk. But now we're going to take a look at the Cape, and sorry, we're going to have to go a lot of switching back and forth between the regions we're looking at in today's video. So we are going to be taking a look at our Cape on the HRRR, and as you can see, as we're getting into the afternoon, the HRRR doesn't develop quite as unstable, develops more of a weakly unstable environment, like a modest instability, generally 500 to 1,000 across the enhanced risk area. However, the NAM3K, which we'll get to in a second, does show greater instability, and I do think that's going to be what's going to prevail. There's a little bit greater moisture a little more moisture on the NAM3K, and that leads to greater instability, and I do think that's going to be the case. However, even with Cape values of generally 500 to 1,000, so a little more modest instability, we still saw how that squall line was able to organize, and we saw how, despite there not being too much instability, that squall line was still able to organize. So even if the instability is a little less than what I'm anticipating, there's still going to be a risk for still going to be a pretty significant risk for severe thunderstorms across portions of Montana. And we're going to take a look at our bulk shear, our deep layer shear. This is what's going to help make up for even if the instability is a little less than what we're currently expecting, kind of like what the HRRR is currently showing. We're going to see how the deep layer shear environment is going to be quite favorable. We're going to have deep layer shear of about 60 knots. That's really going to help organize these storms into squall lines, or maybe supercells if there's an area in areas of lower concentrations of storms. You can still see those supercells out ahead of the line. So that's really going to help organize these storms a lot and help them produce damaging winds and hail. And if we take a sounding here out ahead of the line, we're going to see that our hodograph is fairly straight. And that means that the tornado threat is going to be quite low. We can also see how their temperature dew point spread is rather high. So our tornado threat is none in this sounding, like there wouldn't be a chance of a tornado in this sounding. But because of the straight hodograph, that still supports a risk for hail, and the squall line supports that damaging wind risk. So really we're going to be looking at a damaging wind and hail threat with this event. That's really going to be the primary risk factor. We can't completely rule out a tornado areas further south and east from here, but the chances are quite low at the moment. And again, we're going to show how that shear is still quite strong. Our deep layer shear, our low-level shear isn't too favorable with this system for the most part. Again, another reason why our tornado threat is rather low. But again, we see as we get into the evening hours, which is when the storms arrive, still generally have a low-level, not a low-level, we still have a deep layer shear environment on the order of 50 to 55 knots. So again, that's still pretty favorable. And again, I'm just going to show it quickly, like our 850 jet is generally not going to be too powerful for this event. It's a very small area that has that that stronger low-level jet, but even if we take a look at it, I believe the atmosphere should be capped, and yes, there's a very strong capping inversion, so that would suppress surface-based storm development in that area, so you're not going to see a tornado despite those stronger low-level wind shear in that area. The next thing we're going to take a look at is our lapse rates, and this helps with two things. It helps develop greater instability. You need more than just warm air at the surface. You also need cool air aloft. So the lapse rates are the rate at which temperatures are cooling aloft, and that gives us the cold air we need for instability. But that also helps with getting more hail and larger hail. So we're going to see that overall our lapse rates are going to be above 7, and even further south, above 8 degrees Celsius per kilometer. So that's going to help organize large hail, especially with any supercell that can be sustained. And it wouldn't surprise me if any supercell that does form, like any discrete supercell, does produce an instance or two of very large hail, which is hail greater than 2 inches in diameter. The Storm Prediction Center has not specifically highlighted this, because the probabilities right as of now, there's not enough confidence in it to include a significant, which is a 10% chance or greater in a 25-mile radius. But any discrete cell that does form, given the steep lapse rates, I do believe has a chance of producing hail greater than 2 inches in diameter, though that will probably be fairly isolated in nature. And so now we're going to take a look at our NAM 3K, and I do think the NAM has a little bit of a better handle on the instability with this particular setup. And we're just going to start off with that, and then we'll take a look at our reflectivity output. And we can see how this CAPE, it develops to more of a moderate instability. You can see CAPE on the order of 1,000 to 2,000, and that's really going to help those storms get a more powerful updraft and as such be capable of damaging winds. If the situation that the NAM is showing, which is the one that I believe more right now, that would support those significant wind gusts of over 75 miles per hour. Despite the organization on the RRR, there would be a little bit more uncertainty with significant wind gusts because of the lack of CAPE. Though really, regardless, there could be fairly widespread damaging winds just because our deep layer shear is so strong with this system. But now we are going to take a look at our reflectivity output, and we see how these storms will organize, and we get this squall line just form again here. It's our squall line, and we're going to see how it's going to race eastward. You can even see a bowing segment in the line itself, which is not. You can see a bowing segment in the model that's depicting. So that's pretty significant. Again, if we're just taking sounding out ahead of the environment. It does say that there is a marginal tornado risk with this, and while I guess there could be a tornado since the temperature dew point spread is a little better, the chances are just very, very low, very low, because the photographs are just quite straight, and the storm mode being linear, which favors a damaging wind risk. But you can still see how we have those steep lapse rates here in all levels of the atmosphere, so that's going to support the damaging wind and large hail risk. It's very important to have good lapse rates, because even if you had 100 degree temperature, if the lapse rates are terrible, you're going to have very little instability. If the lapse rates are very low, I should say. And we're going to take a look at this spreading as it spreads eastward later in the day, and we can see how storms do develop, and they're not going to be as high in coverage, but they're still going to be in a favorable environment here. We're going to take a sounding, and we're going to see how there's a strongly unstable environment. And down here, this is where roughly where the 2% tornado is. There is a little more turning in the photograph, so and that's why there's that slightly greater chance of a tornado. It's still a fairly low chance, but it is a non-zero risk with this. Again, damaging winds in here are going to be the primary risk, and the NAM actually develops another squall line here, which is interesting to see if that develops or if the storm stays a little more discrete. If that squall line does develop on the NAM 3K here, that would increase the risk for damaging winds and maybe decrease the risk for hail a little bit. We are going to show the CAPE a little further east because I realized I did forget to do that. And we're going to see how the NAM shows a more strongly unstable environment further south across portions of Nebraska and South Dakota, perhaps on the order of 2,000 to 3,000 joules per kilogram of CAPE. And then we are going to take a look at the bulk shear as well. Again, this is going to be what's going to really... That's the biggest thing that's standing out to me with this event is the deep layer shear. That's probably the best way I can put it. And we're going to see further west, we're going to have shear over 50 knots. And then, with southern extent, there's not going to be quite as much, but it's still going to be sufficient to organize storms into supercells. And that's, that's going to drive that risk for damaging winds and large hail across the slight risk region, which extends for parts of North Dakota, through the entire state of South Dakota, and basically the western half of Nebraska. So it's a fairly large slight risk on top of that enhanced risk. We are also going to show the lapse rates. I know I took a sounding and showed them to you, but I just want to show it to you on a larger scale. And we're going to see that based by 0Z, like this entire area, basically the entire area that's under the slight risk, generally has lapse rates greater than 7. And there's a small exception in western Nebraska, but still, that's still overall very favorable lapse rates for severe weather. One more thing we're going to show, this is just going to show the straight photographs here. We're going to take a look at our surface-based CAPE, and we're going to overlap it with photographs, which can help show tornado potential if they're curving. But we're going to see how we get into the day on Sunday. They're really generally not curving too much. You can see the areas where they are curving, though. Right here, this tiny boundary here, that's where the NAM would be hinting greater tornado potential right along this boundary in South Dakota. But we can see otherwise they're straight, which mostly favors a damaging wind and hail risk. And then we're going to look at this same parameter on the HRR quickly before we wrap up this video. And as we get into the afternoon, we're going to see how there's curving photographs do develop, and this is where there would be that chance for a tornado if a surface-based storm developed, though probably going to be a little further south just because the atmosphere is capped here. I think I forgot about that one just like 30 seconds ago when I was talking about the NAM 3K. The atmosphere is capped over here, so it's probably going to be a little further south, even though there's a little less turning. Let's see. I mean, in this area, the risk of severe weather is lower, likely because of that capping inversion, and instability could decrease with nightfall. So yeah, the greatest tornado potential is going to be probably further south, despite not as much turning in the photograph. And we can see, well, again, there's not too much turning, there's just a tiny bit here in the HRR, and the temperature dew point spread is not sufficient to have a tornado risk on this particular sounding, but a lot of times the HRR mixes out the moisture a lot during the daytime, which does lead to lower dew points, so I do suspect there could be a little more moisture than when that particular sounding said. But one more thing I just wanted to show, I don't think I did at the beginning of the video, is that we do have Tropical Storm Colin has formed off the coast of South Carolina and is currently over the coast of South Carolina, and it's a very lopsided system, so most of the rain bands are staying offshore, but there are tropical storm warnings in effect for portions of the northern South Carolina and basically all of the North Carolina coast, so we could see some gusty winds, especially in the areas under tropical storm warnings, and perhaps locally heavy rainfall with any rain bands that do make their way ashore. But again, there's a lot of shear affecting this system, which I know I talk about shear being favorable for severe thunderstorms, but for tropical storms it tears them apart, so there's shear from the north and west, and it's blowing all the thunderstorms to the east side of the system, and that's causing most of the thunderstorms to stay offshore. So that's going to really limit the amount of rainfall, but really any rain band that does develop could still produce some heavy rainfall. But with that is the end of the video. I hope you enjoyed it. Please consider liking and subscribing, and I will see you in the next video. Bye.